So we figured out that V is equal to 5 at the equilibrium traffic volume before individuals have taken into account into account their effect on the cost of commuting for others. So we've got V is equal to 5. Now we need the price, and all I'm going to do is put the value of V into this equation right here, because if we have V is equal to 5, we put that into this equation, then it'll give us the price. So 5 plus 3 times V, which in this case is 5, so that equals 5 plus 15, that equals 20. Good, so we have 20 right there. And the next thing we need to do is find the optimal traffic volume, the point that is given by this intersection. Let me just draw the lines that we need. And I'll clear a bit of space. Okay, and so once again, all we need to do is set these two equations to be equal to each other. And so we'll use the demand curve and this supply curve. And we'll get V is equal to 10 minus, right? What was our demand curve? 10 minus 0.25 P, 10 minus 0.25. But in this case, the price is going to be comprised of the marginal cost. So 5 plus 5V, 5 plus 5V. Let's see what that works out to. V is equal to 10 minus 1.25 again, 0.25 times 5, and then minus 0.25 times 5, again 1.25V. And now we will add, just reviewing my assumptions here, we'll add 1.25V to both sides of the equation. We'll get 2.25V is equal to 8.75, and now we just need to divide both sides by 2.25 to find out our value for V. So 8.75 divided by 2.25 is equal to 3.888. So we'll just say we could just round to 3.9, I think. So that 3.9. Now the value of the y-axis at this point is going to be given by inputting this 3.9 value of V into this equation right here. So let's do that. So our equation was that the marginal cost is equal to 5 plus 5V. Is that right? Yep. And we're going to input our V of 3.9 into that. So equals 5 plus 5 times 3.9. And that is equal to, getting out my calculator once again, 3.9 times 5 plus 5 is equal to 24.5. 24.5. Hopefully that's the right number. So 24.5. I haven't done this question beforehand. I'm doing it for the first time for this video, so hopefully the numbers work out for us. So we found out the equilibrium traffic volume and the price that's associated with that volume, the marginal external cost. And the last thing that we have to do is to find this value of the toll. So we need to find this distance. And once again, we'll just make this, I'm going to clear some space here, but we already kind of know what that value is going to be, because we know that the external cost is given by 2V. So we know what V is at this optimal point. It's 3.9. So let's just put that in. 2 times 3.9, and that is going to be 7.8, if I'm not mistaken. Let me just get my calculator to double check that calculation. Yeah. And so that's what we expect this value to be. And just to double check, we're going to find the price at this point right here. And we're going to do that by inserting this value of V into this equation here, right? Because we're using this line now, this supply curve right here, to find out this value of P. So we're going to use the equation 5 plus 3V, and V in this case is 3.9. And so let me just get my calculator. 3.9 times 3 plus 5 is equal to 16.7. So that equals 16.7. So we can plug that value into this point here on our graph, and then just subtract 16.7 from 24.5 to find out what the distance is between these 2 points. So that is, what are our values again? 24.5. 24.5 minus 16.7. 16.7. And I really hope that is equal to the value that we predicted of 7.8. Let's see if that's true. I'll just pop out my calculator. 24.5 minus 16.7. And that does, in fact, equal 7.8. I'm very relieved, because I wasn't sure the numbers would work out with this somewhat messy example, but they have. So we found everything we need to know for this question. We found the equilibrium traffic volume at this point. We found the socially optimum traffic volume at this point, and the prices that correspond to those traffic volumes, as well as the toll required to get to the optimum traffic volume. So hopefully you found that helpful, and hopefully these examples helped you to sort of give you a better idea of how these questions on efficient traffic volume work.